Have you ever stopped to think about what a tiny ant and a giant planet could possibly have in common? It's a weird thought, right? But the answer is they both play by the exact same fundamental rules of movement. And today, we're going to unlock those rules together. Let's dive in.
Yeah, sounds a little like a riddle, doesn't it? But the thing is, they're all speaking the same secret language, and that language is motion. By the time we're done here, you're going to be fluent.
All right, so our first rule is all about the journey itself. And it turns out there are two really different ways to talk about the path you take. It's not as simple as you might think.
Okay, first up is distance. And this one is pretty straightforward. Just imagine you've got a pedometer on. Distance is literally just counting every single step you take on a trip. It's the total ground you covered no matter how much you zigzagged.
But then you've got this other thing called displacement. And you can think of this as like the ultimate shortcut. It completely ignores all your twists and turns. It just draws a straight arrow from where you started to where you ended up. And that arrow part is key because it includes direction.
So, let's put that together. Imagine you walk all around a big park for an hour. Your distance could be, I don't know, a couple of miles. But if you end up right back at the same park bench where you started, well, your displacement is zero, a big fat zero. See? They're telling two totally different stories about the exact same walk.
Okay, so that's rule number one. Now, let's build on that with our second rule. Because understanding displacement, it lets us take our normal idea of speed and upgrade it to something way more powerful.
And that upgrade is called velocity. See, velocity isn't just about how fast. It's how fast and in what direction. And that direction part is absolutely critical. I mean, think about the GPS on your phone. It has to know both your speed and your direction to tell you turn left in 500 feet. Same for air traffic controllers guiding planes. It's a huge deal.
All right, let's try a little thought experiment. Imagine you walk 5 meters east. You stop, you turn around, and you walk 5 meters west, right back to where you started. You were definitely moving, right? You covered 10 meters of ground.
So, here's the big question. You were moving, for sure. But what was your average velocity for that whole trip? Think about it for a second.
The answer, 0. 0 meters per second. I know, that sounds completely bonkers, but I promise you, it's true.
And here's why. Remember displacement? It's the straight line from start to finish. Well, since you ended up exactly where you started, your final displacement was 0. And because velocity is all about the change in displacement, if that's 0, your average velocity has to be 0 too. Mind-blowing, right?
Okay, so we've got position and we have velocity. But, things get really interesting when velocity itself starts to change. And that brings us to our third and final rule, the ultimate change-up.
That change is what we call acceleration. Now, here's the part that trips a lot of people up. Acceleration isn't just hitting the gas and speeding up. It's also hitting the brakes and slowing down. And get this, it's also just changing your direction. A car going around a corner at a perfectly steady speed, it is constantly accelerating because its direction is constantly changing. This one idea is how we get everything from crazy roller coasters to cars that are safe to drive.
Let's make this super simple. Look at this timeline. At 0 seconds, the car is not moving. 1 second later, boom, it's going 1 meter per second. After 2 seconds, it's at 2 meters per second. At 3 seconds, you guessed it, 3 meters per second. You see that pattern? Every single second, it adds another meter per second to its velocity. That steady change, that's acceleration.
So any change in velocity is acceleration. And you know what the most famous, most constant example of acceleration is? It's something you're feeling right now, every single second of your life. It's gravity.
Here on Earth, gravity's pull causes a constant acceleration of 9.81 meters per second squared. Now don't let that squared part scare you. It just means meters per second per second. In other words, for every single second something falls, it gets faster by 9.81 meters per second. So it just keeps picking up speed faster and faster and faster.
But that number, it's not the same everywhere in the universe, not even close. Just look at this chart comparing Earth to the Moon. On the Moon, the acceleration from gravity is only about 1.6 meters per second squared. That is a huge difference. It's only about 1/6 of what we're used to.
And that's why you see those amazing videos of astronauts kind of bouncing and floating on the moon. With gravity pulling so much less, its effect, its acceleration, is way, way gentler.
Okay, so let's bring this all home. Let's put all the rules together. When you understand these few key concepts, you can literally build a complete picture of why anything moves the way it does.
So here it is, your new motion toolkit. You've got distance, that's the total path. You've got displacement, that's the straight line shortcut with direction. Then there's velocity, how fast your displacement is changing. And finally, acceleration, any change in that velocity. See, when you break it down, it's all connected.
And please, don't think this stuff is just for basic problems. These ideas, they're the absolute bedrock of physics. They don't just help us understand a car ride, they help us understand the orbit of planets, the path of comets, and even the movement of entire galaxies across the universe.
So I'm going to leave you with a challenge. As you go about the rest of your day, keep these rules in your head. The next time you see a car turn a corner, I want you to think acceleration. When you walk somewhere and then come right back, think, my displacement is 0. Now that you know the rules, what other motion are you going to notice today?